Okay, so in this what have we got here? Here we've got a reaction where perchloric acid is reacted with phosphorus pentoxide, and that's produced phosphoric acid and dichlorine heptoxide, right? And effectively, we've been asked to calculate, well, what is the mass of dichlorine heptoxide which has been produced in a reaction? And the mass we've been given is the mass of the perchloric acid, right? So this is a process of, well, okay, well, how are we actually gonna figure that out? Okay, well, the way I'm gonna approach this is, well, let's consider what we actually need to get and what we have been given. So as the question specifies, we need to get the mass of the chlorine heptoxide, right? The dichlorine heptoxide. But how do we get there? Well, we're going to need to effectively consider the amount of substance of the dichlorine heptoxide, right? And we would know from the equation of mass, molar mass, and moles that the mass m. Let me use a different. The mass m is equal to the moles multiplied by the molar mass mr, right? But here's the thing. In this case, we're looking at amount of substance. So if we rearrange this by dividing both sides by the molar mass, so divide both sides by mr, this would then cancel, and we get that the moles, the amount of substance, right, would be equal to, as you can see, the mass divided by the molar mass, right? We don't have the molar mass, right? And as we discussed, we're trying to figure out the amount of substance, which would then give us the mass. We don't have the amount of substance yet, right? However, when we consider the fact that we have been told the amount of substance of, well, we haven't been told the amount of substance, but we've been told the mass, right? And we've been, we've got this formula. In effect, on the reactant side, we can use stoichiometry to then later figure out, well, okay, based on this, this is what the amount of substance of the target product that we've been asked about is, right? In effect, what I'm saying is we need to consider what's the amount of substance for this reactant. And that's what I'm going to look into now. So we've been told that it's 7.6 grams. And we know that for amount of substance, as we literally just discussed here, it's equal to the mass divided by the molar mass. Now we have the mass, which is given in the question, 7.6 grams, right? So the N is equal to 7.6 grams divided by, right, the molar mass. But do we have the molar mass? Well, let's figure that out, right? So HClO₄, right, HClO₄, we're going to try and figure out the MR, the molar mass of HClO₄ is equal to, and if we refer to the periodic table, so the relevant elements in this case, of course, hydrogen, chlorine, and oxygen, right? These would be some of the key relevant elements. If we look at the relative atomic masses of them, we can use that to calculate the molar mass. So for H, it's going to be just a 1, right? So 1. And ordinarily, I would write 1 multiplied by its frequency of occurrence. But in this case, the frequency is 1. So I'll just write 1. Okay, so and then for chlorine, we've got, again, it occurs only once. But the relative atomic mass for chlorine, 35.5. So I'm going to put that there, 35.5. And then we consider for oxygen as well, right? So for oxygen, it's going to be, and let me just going to move this down a little bit. So for oxygen, it's going to be 16, right? but that actually occurs here. As you can see, it occurs 4 times, so it's going to be 16 times 4, right? And if you calculate that, it's going to tell you what the molar mass of the HClO₄ is. So I would invite you to have a go and see what value you get out of that. Okay, so if you did have a go, you should have got 100.5, and its molar mass. In this case, the units are going to be grams per mole, right? Now, with that value, what we can do is divide the 7.6 by the 100.5. Okay, so divide that by the 100.5, and this is going to give us our number of moles. So I would invite you again to have a go, see what you get if you do that calculation, and you should find that you get 0.0756219, right? So we now have a value for our moles, right? And this is the value of the moles for the the perchloric acid, the HClO₄. Okay, what can we do with this in order to try and get to what our actual objective in this question? Well, what does the stoichiometric ratio concerning these amounts of substance? What is the question? What is the balanced equation, which is what we have here? What does it tell us? So if we look at the balanced equation, whether it's here or up here, we can see that the coefficient corresponding with the perchloric acid is 12, right? And we can also see that the coefficient corresponding with the, and in this case, we're looking at the dichlorine pentoxide. You can see that the coefficient associated is 6, right? So if we now actually put together a ratio comparing the two down here, so this is going to be the moles of the perchloric acid, so HClO₄, compared to the moles of the dichlorine pentoxide, so Cl₂O₄. Clearly, this is a ratio of 12 to 6, right? So it's going to be a ratio of 12 to 6. That is to say that for every 12 moles of this, we're going to have 6 moles of this. Now, if we work on simplifying this, so because it's a ratio, we can simplify it if there's some common factors. And if we divide both sides by 6, we're simply going to get a ratio of 2 to 1, right? Which means for every 2 moles of the perchloric acid, we're going to get 1 mole of the dichlorine pentoxide. Okay, what does that mean? What is the implication for our moles here? Well, the implication is actually that the moles of, and I'm going to just write this as I kind of explain it, but in effect, the moles for the Cl₂O₄ is going to be equal to simply 0.5 multiplied by the moles of the HClO₄. In other words, it's going to be half, okay? And we have that value actually, so that's going to be 0.5 multiplied by this value we've got here, which I could just add the units there, but it's going to be 0.75. No, that is, I've missed a 0, haven't I? 0.0756219 moles, right? Now, if you calculate that, I mean, I would invite you to have a go and see what you get when you do calculate that. What you should find is that you get 0.0378109. That's in moles. Okay. So we've now calculated effectively the amount of substance of the Cl₂O₄, right? But what we need now to do is to get the molar mass of that value. So well, not of that value, but the molar mass of the actual, you know, the dichlorine pentoxide, right? We need to get the molar mass of it, which we can get from the periodic table, or we can calculate from the periodic table. So that's going to be Cl₂O₄. So if you go over here, MR of Cl₂O₄ is going to be equal to, so as we established, the relative atomic mass for the chlorine is 35.5, right? So that's going to be 35.5 multiplied by, so the coefficient we can see here is 2, so it's going to be times 2 plus, and then for oxygen we know that the relative atomic mass is 16, right? So we're going to put 16, and that's going to be here, as you can see, it's going to be multiplied by 7, right? So if you do that calculation, you'll find what the molar mass of the Cl₂O₄ is. And if you did that calculation, you should have got 183, right? And that's going to be in grams per mole. Okay. Now, I'm going to now use that number, right, in our calculations to work out the actual mass. And the equation I'm using is going to be that the mass is equal to the number of moles multiplied by the molar mass, right? So we've already established that the molar mass of Cl₂O₄, that 7 is not well placed, that's O7 is equal to 183, right? So what we can do is simply say that the mass is equal to, in this case, 0.0378109 multiplied by 183, and that is going to give us our mass. And if you go through that calculation, what you should find you get is 6.9193947, and that's going to be in grams, right? Now let's refer back to the question briefly. The question states we need to calculate the mass of Cl₂O₄ produced from this reaction. And one of the points which I maybe didn't I kind of glossed over it, but it is something I was thinking about as I was doing this calculation. P₄O₁ was stated in the question to have been produced in excess, right? Now, because of that, we would have been able to infer that actually the limiting reagent is the HClO₄, right? And that was the basis on which I then decided that actually if you run the calculations based on HClO₄, which is the limiting reagent, you're going to be able to work out accurately, well, what's the mass produced of Cl₂O₄, right? Because the assumption is that all of that reacted, and it's that fixed amount which we were told. Okay, So as I said, referring back to the question, you can see that it specifies give your answer to a maximum of 2 decimal places, right? Now, our answer we've got of the mass is to quite a number of decimal places, right? I think it's approximately 7 decimal places, but it says a maximum of 2, so we're going to need to do some rounding. And if we do round this, so that's going to be equal to 6 point, and with 919 we would take the 1 and round that up to 2, right? So 6.92, and then that's going to be grams, right? So in this case, the mass of Cl₂O₄ equals 6.92 grams to 2 decimal places.